Okay, we are looking at a example for a position time graph. We're looking at over the course of these different intervals here, 1, 2, 3, 4, 5, 6, 7, 8, will our object be at rest, constant positive velocity, constant negative velocity, or increasing or decreasing speed? And since we have a position graph here, we know that the slope of a position graph will give us that velocity. So if we look at our first interval here, number 1, I like to look at our slopes as tangent lines, and I can either do this with my hand, kind of rolling it along the line, or a pencil showing it along the line, or if I draw tangent lines like this, I'll notice here that my tangent line is becoming more vertical. And when it becomes more vertical, this means I'm speeding up. It doesn't tell me if I'm speeding up in the positive or negative direction for what we're looking at right now, but right now we're just saying, is this increasing or decreasing speed? Okay. Technically, we're going in a more negative direction because we're coming back to the 0, but because it is a more vertical line, we are indeed speeding up. So for number 1, we have a D. For number 2, this is a straight line. This is just a straight line between 2 and 3, which means the slope is constant. The question is it a constant positive or a constant negative slope? And since that slope is pointing downward, it's a constant negative slope, which means a constant negative velocity, C. For number 3, we have a curve again, which means that we're going to be either increasing speed or decreasing speed. If I draw my tangent lines, I start pretty vertical, and then it looks like I'm flattening out. And since I'm flattening out, that means I'm slowing down. That means I'm decreasing my speed here. That's E. For number 4, we've got a straight line again, so we have a constant. And since that's rising to the right, that's a constant positive slope there, so a constant positive velocity. For number 5, we've got a curve, so it's going to be either D or E, an increase or a decrease. It starts kind of flat, and it becomes very steep, so we must be increasing our speed there. For number 6, we start very steep, and then we kind of shallow out a little bit, so we're slowing down, which must mean we're decreasing our speed. And then in number 7, we went from that kind of flat to much steeper. And since we're much steeper here, we're increasing our speed. That is D. And then for number 8, we're very steep here, and then we're flattening out, which means that we're slowing down. If you're a physics aficionado and you're like, this is weird on these kind of vertexes, yes, I realize that we are accelerating by an extreme amount over those points of time, but that's not what we're talking about now. We're just looking at some basic things here, okay? So that's how we can determine what's going on here in these types of graph. Something we didn't see in this one was at rest. We are at rest on a graph for a position time graph when our slope is perfectly flat, a horizontal line. We didn't have one here, so we didn't have an at rest. Another thing we can do with this graph is if we'd like to calculate the distance traveled and the displacement between some intervals, we can do that as well. So let me clean this up real quick. And let's look at the intervals between 2 and 7 seconds. So here, let's actually do this properly. 2 seconds is, let's see, 1 second, 2 seconds, so it is right here. 7 seconds, though, is not out here. 7 seconds is 5, 6, 7. 7 seconds is right here. So we'd like to find the distance traveled and the displacement between these red markers, okay? So in order to get the distance, distance is every single step you take, and we read the steps off of the y-axis. So between this initial red point and the second red point, I'm going down 1, 2, 3, 4, and then I need to go back up 1, 2, 3, 4. So I went down 4, and then I came back up 4. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 meters of distance. Some people always make the mistake of counting down 1, 2, 3, 4, and then counting over 1, 2, 3, 4, 5. These orange markers don't mean anything. That's time. We don't read distances off of the time axis. Time is just passing for us. What we really care about is just how have we gone with the position up and down. In terms of our displacement, remember displacement is a vector. It is just the final minus initial positions here. If we take a look at this, Our final position here is at 0. Our initial position is at 0. 0 minus 0 is 0. So that's our displacement. Why don't you pause the video for a second? Try this from 7 seconds to 12 seconds. That's going to be at the purple marker here, all the way out to this purple marker right here. See if you can get a distance, see if you can get a displacement, and then unpause the video and we'll work through it. Bloop. That's the pause phase. Okay, here we go. For distance traveled, we are going from purple to purple, and I need to go up and then down and then down. So I'm going up 1, 2, 3, 4 to get to the top here. So that's 4, and then I got to go down again. 5, 6, 7, 8, and then I got to keep going down. 9, 10, 11. So it was a total of 11 meters that I went through. As for the displacement, it's just final minus initial. My final position, if I read it from the graph, is right here, -3. So that's -3 minus the initial position of 0, which means my displacement, or my change from the beginning, is -3 meters. And that's it. That's how you read a graph like that. So hopefully this example kind of helped you out as you're looking at it. Remember, distances always have to be positive. Displacements can be positive or negative. But with that, this position graph is finished. Take it easy.